Hello everyone, I'm Siddharthan. Currently, we are in the eighth module of our hands-on machine learning course, and in this eighth module, we are discussing about the topics such as cross-validation, hyperparameter tuning, model selection, and model evaluation. The previous video was on accuracy score and confusion matrix. So I explained you in detail about what is the concept behind this accuracy score and how we can find this accuracy score and confusion matrix in Python. So in this video, we are going to discuss about some more important evaluation metrics that we have that includes precision, recall, and F1 score. As I have told you, these are some of the important model evaluation techniques that we have, which is used to tell us whether a model is good or bad, whether the performance is well or it is not that good. So this is what the importance of precision, recall, and F1 score is. So before diving into these topics, I'll just give you a quick recap of what we have seen in this accuracy score and confusion matrix. So if you wanted to get a clear understanding on this topic, please watch the previous video. I'll also give the link of that video in this video description. So we know that accuracy score is a very important evaluation metric that we have in machine learning, especially in classification machine learning problem, where we will try to classify the data points into different types or classes or categories. So you can say any of them. So it is basically the ratio of number of correct predictions made by our classification model divided by the total number of input data points that we have. So this is the ratio. So number of correct predictions divided by total number of input data points that we have. So this is the formula for it. And the value that you get when you divide this number of correct predictions by the total number of data points will range between 0 and 1. And if you want this in percentage value, you can simply multiply it with 100. So you will get the value in percentage. Okay. So 90 percentage basically tells you that if you use your model to predict for 100 data points, your model will give you correct predictions for 90 data points. So this is what accuracy score means. Let's try to understand this with the simple example that we have discussed before as well. So let's say that the number of correct predictions that is made by your model is 128 and the total number of data points is 150. So you simply like divide 128 divided by 150. So you will get the accuracy score as 0.853, and when you multiply it with 100, you will get the accuracy score as 85.3 percentage. So 85.3 percentage basically means out of 100 data points, your model can give correct predictions for 85 data points. Okay, so that is what this accuracy score means. And you can import this accuracy score from sklearn.metric. So we have seen this before. So the main limitation when it comes to accuracy score is that it is not at all reliable when you have uneven distribution of classes. So what is meant by this uneven distribution of classes is, let's say that you are building a model that can predict whether a person has diabetes or not. So in that case, the two classes are person with diabetes and a person without diabetes. Let's say that there are like 500 patients in that particular data set, and let's say that out of the 500, 400 people doesn't have diabetes and 100 people have diabetes. So this is what we call an uneven distribution because there is almost a 4 is to 1 ratio. So when you have two classes or even when you have multiple classes, when the distribution is even, then only your accuracy score can give you like reliable values. So if there is like uneven distribution, in that case your accuracy score value will be high but it is not reliable. So if you want to understand this much better, please watch the previous video. I have explained that in detail with an example, so you will understand that better. So when we have this kind of confusion, when there is like where is this uneven distribution, so that is where we will move on to the metrics like confusion matrix. So as we have seen in the previous video, confusion matrix is simply a matrix, and again it is used for evaluating the performance of a classification model, and it gives the information that the accuracy score cannot give. So accuracy score will just give you the percentage, but this percentage can be deceiving, so we cannot rely on this completely. So we have this confusion matrix where we have four terms. So TP basically means true positive, FP means false positive, FN represents false negative, and a TN represents true negative. I hope that most of you would probably know this. So if you don't know what these things means, I'll explain you about this. So we can consider these two things. So this true class is basically my actual label values or actual class. Okay, it's positive and negative. You can think about this positive as person with diabetes and negative as person without diabetes. And you can also think about this positive as COVID positive and negative means COVID negative. So you can also consider that example. And this is the predicted value. Again, we have this positive and negative. So this thing in this horizontal axis represent my true class or actual labels that is present in my data set. And predicted class represents the labels, the two labels, negative and positive, predicted by my model. Now let's try to understand what these four terms means. First, we have true positive. So what does this true positive means is, so let's say that 50 people in the data set, let's say that data set contains like 150 data points, and out of these 150 data points, 50 people have COVID infection positive. Okay, so they have like COVID positive, and out of those 50 people, let's say that our model is predicting correctly that 40 people have COVID. Okay, so this is what we call as true positive. So in this case, the true positive count is 40. Okay, so the total number of the total number of people with positive COVID infection is 50, but our model is predicting correctly only for 40. So your true positive count will be 40. So it is basically, so the actual value and your predicted value are matching. So this is what we call as true positive. And TN means true negative. Okay, so let's say that out of we know that 150 people, 50 people have COVID infection, so remaining 100 people doesn't have COVID infection. Let's say that in this case, you can say that your model is predicting that let's say 80 people doesn't have COVID infection. Okay, so that is what we call as true negative. So in this case, the actual value is negative and the model is also predicting the label as negative. So this is what we call as true negative. So true positive and true negative basically are your correct predictions, and false negative and false positive are your wrong predictions. So we cannot get this information when we use this accuracy score, because we will get only the percentage value. So false positive means the person doesn't have COVID. So they have like negative COVID infection. So this is my true class. So actually they don't have COVID, but the model has predicted that they are COVID infection positive. So this is what we call as false positive. And what this false negative means, so a person actually has COVID infection, as you can see this positive here, but they are predicted as negative. So this is what we call as false negative. So if you take this quadrant, you just have to compare these two things. So this class and this class. So if these two things match, it is correct prediction. Okay, so in this case, if you see this TN fourth quadrant, so the horizontal class that we have is negative, and the this vertical class we have is also negative. So these two things are matching. So we can say that these are correct predictions. So if you see the second quadrant, which is false positive, so here we have negative, here we have positive. So we know that there is mismatch of true class and predicted class. So our model is predicting these things wrongly. And in this case, if you see this Fn false negative, we have positive in the true class and negative in the predicted class. So this is what these four things mean. Okay, so true positive and true negative contributes to your correct predictions made by your model, and false positive and false negative contributes to the wrong predictions made by your model. So this is like very important for us in order to understand whether a model is performing well or not. So basically, in ideal situation, you must have high number of true positive and true negative, and low number of false positive and false negative. Okay, so this is same as saying your model should have several or high number of correct prediction and minimum number of wrong prediction, which is false positive and false negative. Now we know that accuracy score is kind of a percentage value. It is like a single value, but when you build a confusion matrix, we have four terms, so four numbers are there. So our idea here is to build something, to build an evaluation metric that will give you a single score, so that we can understand the performance of our model better. So if you see this true positive, false negative, and true negative are basically the number of data points that is being predicted. So this is where precision recall and the F1 score comes into play, where it will take into account these four terms. Okay, so these correct predictions and wrong predictions, so it will take all these things into consideration, and it will give us a better score. Okay, so let's try to understand how we can understand this precision recall and F1 score. So I'll start with the formula for precision, and after that I'll explain you what is the significance of this. Precision is equal to true positive divided by true positive plus false positive. So this is the formula. So we know that true positive, which is my TP, FPTN, and so on. So you can understand that. So precision is equal to TP or true positive divided by true positive plus false positive. And this value also range between 0 and 1. And if you want, you can also multiply with 100 in order to get it as percentage value. Now, if you just memorize this formula, it is not a good way, but you this actually seem confusing. So you may like confuse this with false positive, with false negative, and so on. But there is a better way to understand this. Let's try to understand what does this mean. So I'll give this confusion matrix that we have seen before. Now look at this denominator. So in the denominator we have true positive plus false positive. Let's try to locate this in this confusion matrix. So this is nothing but my true positive and false positive TP and FP. If you look at this, these two things actually mean the data points that are predicted positive by my model. Okay, so this is my predicted class, and in this case, the predicted class is positive, as you can see, and this is like the positive values that are correct. So here, the actual value, actual label, which is positive, matches with the predicted value positive. So this is again the labels that are being predicted as positive, but they are actually negative. So what is meant by this precision is we take this true positive divided by the total number of predicted positive. Okay, so total number of predicted positive is nothing but true positive plus false positive. So you just have to look at this confusion matrix. So like precision is nothing but true positive divided by total predicted positive, because we know that if you just put a square here, so true positive plus false positive, so these are nothing but all the data points that are being predicted as positive. Now let's try to understand what does this signifies. So precision is the ratio of number of true positive to the total number of predicted positive. It measures out of the total predicted positive how many are actually positive. So this is what precision means. So we know that it is a ratio, and we know that the value ranges between 0 and 1. Now look at the second statement. It measures out of the total predicted positive how many are actually positive. So let's say that there are 500 people, and out of these 500 people, let's say that our model is predicting, let's say that 200 people have COVID infection. So it is like a positive predicted class. But in the actual reality, let's say that all 200 people doesn't have COVID infection. Only like 150 people have COVID infection. So in this case, the number of true positive value is 150, and the total predicted positive is 200, right? So I'll just repeat this again so that you can understand this better. So there are 500 patient, and out of this 500 patient, 150 people actually have COVID infection. Okay, but your model is predicting that 200 people is having COVID infection. So in this case, if you try to build this precision, the total number of predicted positive is 200. Okay, so it should go to this denominator, and the true positive is 150. So you will try to find this value, and this is my precision. So it will tell you what percentage of value is true positive out of this total predicted positive. Okay, so this is how you can understand this precision. And the importance of precision is that this false positive, so precision measures the error caused by false positive, as we have discussed in this COVID-19 infection. So it takes into account mainly the false positive errors. So it is measures the error caused by false positive, and hence it is a good evaluation metric when false positive predictions are critical. So this part is very very important. So we know that we have this accuracy score, and we have this confusion metrics, precision, recall, and F1 score. And the interesting thing here is you don't have to take into consideration all these evaluation metrics. You just need like few metrics, but there is an interesting key that is hidden here. So, whenever your false positive predictions are critical, whenever you don't want to make false positive predictions, in that case, you try to have a model that has a minimum precision. Okay. So, one such example is face authentication. So, let's try to understand this sentences better. So, it measures the errors caused by false positive. If the number of false positive is very high in your model, in that case precision value will be low. If you have like less false positive values, in that case your precision value will be high, because we know that false positive is in the denominator, and it is like inversely proportional. Now let's try to understand what we mean by saying that false positive predictions are critical. So let's consider this example of face authentication. Let's say that I have installed a face recognition system in my door. So there is a camera that will detect my face whenever I come in front of the door, and only when my face is detected, the door will unlock. Okay, so it will happen automatically. So in this case, true positive is when I stand in front of the door, and it will scan my face, and it will tell that this person is Siddharthan, and the door will open. So this is what we call as true positive, because in this case the actual class is my name, and the predicted class is also my name. So in this case, the two things are matching, and then we have this true positive. Now let's try to understand what is meant by this false positive. Let's say that someone else is coming and they are standing in front of the camera, and this face recognition system mistakenly tells that that person is Siddharthan. So this is what we call as false positive. So in actual reality, it is not positive. It is actually negative, which means it is, so that person is a different person, but the model or the face recognition system is telling me that it is me. So this is what we call as false positive. So in this case, false positive rate is very critical, right? So in the case of face authentication, we have to minimize the number of false positive that we have. So it shouldn't like recognize different person as me. So this is very, very important. Whereas if you consider the rate of false negative, so what does this false negative means? I stand in front of the camera and it tells me that you are not Siddharthan. So this is what we call as false negative, which means in as a true class, in reality it is me. So consider that positive is my name, negative is some other people. So it should open the door only when it is me. The person standing in front of the camera should be me. Okay. So false negative means I'm standing in front of the camera, and it is, instead of predicting my name, it is predicting that this person is someone else. So this is what we call as false negative. And in this face authentication, in most cases, false negative is not a big issue, because I can like redo this. I can like reset this camera, and I can stand in front of the camera again, so that I can be detected correctly. Whereas false positive is very critical, because there can be someone who doesn't belong in the home, and in that case, if the face recognition system unlocks the door, that becomes a problem. So in this case, false positive value is critical. So we will try to minimize this. So whenever you wanted to build a system, or whenever you have a problem statement in which you cannot have several false positive, in that case we will try to build a model which has like good precision score. Okay. So precision score of 0.95, which is like 95 percentage, will tell you that like if I scan in front of like that camera like 100 times, it will correctly predict me for 95 times, and five times different people will be predicted as me. Okay. So that is what we mean by this precision of 95. Okay. So if we consider this COVID-19 example, so precision of 95 means, 95 percentage of the people are predicted correctly as COVID infection positive people, and false positive. It means like 5 percentage, like out of 100 people, 5 people will be wrongly considered as COVID infection positive. So this is what we mean by this precision, and this is where like precision comes into play. So whenever you have a business problem statement or any problem statement where false positive value is critical, in that case we should build a model that has a good precision score. That means like high precision score. Now, let's understand about this recall. So again, let's try to understand the formula. Recall is equal to true positive divided by true positive plus false negative. So you don't need to memorize these formulas. So you don't need to memorize this. You just need to understand this one. So second formula is easy to understand, and it is like easy to interpret what this means. So precision means true positive divided by total predicted positive, and recall is true positive divided by true positive plus false negative. Now let's try to understand why we are choosing these two terms alone. Again, we are going to the confusion matrix image that we have, and we know that this represents my true class or the actual values, and this y-axis represents my predicted class, positive and negative. Now let's try to group this true positive and false negative. So this means true positive and false negative. If we draw a line here, what this basically means is total number of data points that is positive as true class. Okay. So we can write this as recall is equal to true positive divided by total actual positive. Okay. So what this total actual positive means, again, let's say that there are 500 people and we are building a model that can predict COVID-19 infection. And out of this 200 people, let's say that let us say that 250 people have COVID-19 infection positive. So all these people have COVID-19 infection. How many people? 250 people. But our model is saying that out of 500, 200 people is COVID-19 positive, and let's say that remaining are false negative. So remaining doesn't have COVID-19 infection. So in this case, the true positive value will probably be, so if we consider like the true positive, so I'll just repeat this once again. So out of 500 people, actually speaking in the real life, 250 people have COVID-19 infection positive. Okay, but our model is saying that only 200 people have COVID-19 infection positive and remaining 300 people doesn't have COVID infection. So here the true positive count is 200. Okay, and the false negative count is 50, because the total number of people with COVID-19 infection positive is 250. Okay, so true positive count is 200 and false negative count is 50. So these two things contribute to your total actual positive. So you can think about this total actual positive as total number of people in real life that has COVID-19 infection, but in this case the model is predicting wrongly. So you can understand this recall as the ratio of number of true positive to the total number of actual positive. So it measures out of the total actual positives how many are predicted as true positive. So this will again, it is the ratio and the value will range between 0 and 1. So 95 means like it's similar to 95 percentage, but this is not, this 95 percentage is not similar to 95 percentage of accuracy score. So this is different. So this percentage is different. So it measures out of the total actual positive. So in this case, if you think about it, so 250 people are actually they are like positive for COVID-19, right? So out of 250, we have the true positive rate as 200. So here the recall will be 200, which is my true positive, divided by total actual positive is 250. So the answer that you are getting is your recall. Okay, so as we have discussed before, precision is useful when the false positive predictions are critical, as we have seen in this face authentication example, whereas recall is critical when the false negative predictions are very very critical. Let's try to understand this. So recall measures the error caused by false negative. So if there are like several false negative, predictions in your model, in that case, a recall value will be less. So if your false negative value is count, your recall value will be high. So our main goal is to have, maximum value of this precision and recall. Okay, so it measures the error caused by false negative, and hence it is a good evaluation metric when false negative predictions are critical. So there can be like business problems and problem statements where you should not have several false negative values. So your model should not like predict this false negative value. So in that case, we try to focus mainly on recall instead of like precision. So we need precision as well, but this recall we will be giving high importance. Let's try to understand why this is. And I'll also give you an example of when this false negative predictions are critical. So one such example is diagnosis. So let's say that let's say like we are let's consider a serious this is like cancer. So let's say that we are building a machine learning or deep learning model that can predict whether a person has cancer or not. So in this case, true positive means a person has cancer and the machine learning model is predicting that this person has cancer. So false positive means actually that person doesn't have cancer, but the model is predicting wrongly that that person has cancer. So this is what we call as false positive. So in this case, false positive is not that much important for us, because if the model is predicting wrongly that this person is having cancer or something, in that case they may check one more time to to get assured that whether there is actually this particular disease or not. So in this case, false positive is critical, but it is not that critical compared to false negative. Now we have to think about this false negative, which is like very very critical in this case. So what this false negative means is, actually these people have cancer positive. So these people are affected by cancer, but the model is telling that these people doesn't have cancer. So this is very very important, because diseases like cancer requires like immediate treatment, right? And if the model is predicting wrongly that this person doesn't have cancer, this is like a huge problem, because they need to get the treatment quickly. So in this case, false negative rate become very critical. So our model shouldn't make high number of false negative. So this is where the metric like recall comes into play. So if you have high number of false negative, your recall value will be low. So if you're building a system like cancer diagnosis or something, you must have high value of this recall. Okay, so it shouldn't make several false negative predictions. Whereas we know that previously we have discussed about this precision, where our focus was mainly on false positive, because in that case it cannot make like wrong predictions, which is my false positive. So in this case, false negative becomes critical. Okay, so this is where precision and recall comes into play. It's not like you build a classification model and you calculate this accuracy score, confusion matrix, and you just calculate this precision, recall, and F1 score. So it shouldn't be like this. So the focus or the importance for this precision and recall depends mainly on the problem statement that we are working and the nature of the prediction. So if the false negative predictions are very critical, in that case we should have high recall value. If false positive value are critical, as in this case the precision value should be kind of we should have like high precision values. So that is what the difference between this recall and precision is. And now let's move on to the next metric that we have, which is F1 score. So the F1 score is more of a combination of this precision and recall. Okay, so it is an again important evaluation metrics when it comes to binary classification problem. So all this precision and recall also we use in binary classification, where we are predicting between two classes. So in the previous example, whether a person is having a cancer or not, and in the precision example, whether the person in front of the camera is Siddharthan or it is someone else. Okay, so this is what we call as binary classification problem, and F1 score is again an evaluation metric for binary classification problem. And what it does is it combines the values of this precision and recall, and it is basically an harmonic mean of precision and recall. Okay, and as I've told you, these things, precision, recall, and especially F1 score is very much useful when the data set has imbalanced classes. As I've told you, imbalanced classes means if you have two classes, one classes will have several data points and one classes have very low data points. Say for example, let's say that we are building a system that can look at an image and say whether this image represents a dog or cat. If you have like 800 dog images and 200 cat images, so this is like a very imbalanced classes. So in that case, accuracy score is not at all reliable. As I've told you, if you wanted to understand about this imbalanced class and why this affects accuracy score, please watch the previous video. Okay, so whenever you have this imbalanced classes, comparing to accuracy score, F1 score is a better alternative. And also, we have seen that precision we use when the false positive predictions are critical, and we use this recall, like we focus mainly on recall when the false negative predictions are critical. And the thing about this F1 score is, let's say that in some cases both false positive as well as false negative value can be critical, right? So they are like equally critical. So in that case, we cannot choose between precision and recall, so we will go with F1 score, so that we have a more reliable kind of metric. And the formula for this F1 score is, F1 score is equal to 2 into precision into recall divided by precision plus recall. So this is what we call as the format of harmonic mean. So this F1 score is a harmonic mean of precision and recall, and this is the formula. So it's 2 into precision into recall divided by precision plus recall. So it kind of combines both this precision and recall, so that we have a better model that has good precision as well as like good recall as well. So I'll just, this is the last part of this video where we just take a simple example and try to calculate this precision, recall, and F1 score. So this is the confusion matrix that we have. So you can just think about anything like this positive means like COVID-19 positive and COVID-19 negative, or you can also think about positive means like people with diabetes and negative means people without diabetes. True positive means like people who actually have diabetes and they are predicted as they have diabetes. So false negative means um, false negative basically means, so they have diabetes but they are predicted as they don't have their diabetes. So this is what we call as false negative, and so on. I hope that you understand this at this point. Okay, so in the previous case, we add this true class or the actual label or actual class in the x-axis. In this particular image we have this in the so the actual value, actual label or true class is present in the y-axis. So this is not like that important, so you just need to understand this better. So in this case we have just flipped this one. So it's not that predicted class should be in y-axis and true class should be in the x-axis. It's not this one. So in this case it is kind of flipped in this particular image. And now let's try to calculate this precision, recall, and F1 score. So we know that the precision, the formula is true positive divided by true positive plus false positive. The other way of remembering this precision is true positive divided by total predicted positive. So you just need to plug in these values. So true positive, which is my TP, is 50, right? So it will be 50 divided by 50 plus 5. So true positive, we know this, it is 50, and false positive. So false positive is my FP, which is equal to 5. So false positive means that person doesn't have any infection or doesn't have diabetes, but they are predicted as they have positive infection or positive diabetes. So that's what we call as false positive. So it's basically 50 divided by 55, and the value that we get for precision is 0.91. Okay, so it is basically the percentage of true positive in your total predicted values. And for recall, so true positive divided by true positive plus false negative, and the other way to remember is, as we have seen, it is true positive divided by total actual positive. Okay, so it is my recall, and we just need to plug in the value. So true positive, we know that it's 50. So 50 divided by 50 plus false negative value is 10. So in this case, false negative is the count of false negative is I than false positive, right? So here it will be 50 divided by 50 plus 10 because of this 10, and in this case the recall value will be 0.83. As you can see, in this case, false negative number of false negative count is 10, which is like I. So we have this recall value which is low. So if you compare this false positive value and false positive value is low, right? So it is 5 and false negative is 10. So this is why we have this precision value as I precision value. So this is why I told you, like, precision will try to calculate the error caused by false positive. So if we go to the previous slides, so here I mentioned that precision measures the error caused by false positive, and recall measures the error caused by false negative, right? So in this case, the number of false negative is I, so hence we have a lower recall value, and the false positive error is low, so we have I precision value. And now we have this precision and recall, and now we can plug in these values to this F1 score formula, which is 2 into precision into recall and divided by precision plus recall. So when you do this, the final answer you get is F1 score is 0.87, which is more of a combination of this precision and recall. So we get a overall picture of what this model performance is. So how the model is, whether it is like working well, it is making good predictions or not. So this is like much reliable compared to an accuracy score, especially when there is an imbalanced class of data. Okay, so I hope that you have understood all these things clearly, and this is like a very important concept, and this particular thing about precision, recall, and difference score. So this question will be asked in several interviews, so you have to be clear conceptually about this precision, recall, and difference score. And in the next video, let's try to understand how we can calculate these values in machine learning in Python. So it will be an hands-on value where we will try to have a trained machine learning model, and we will try to calculate these values of precision, recall, and difference score. So that's it from my side, and I'll see you in the next video. Thanks for watching.